In this training byte, we will run the simulation for the topology that we had created in the previous training bytes, and analyze the results. As always, for more detailed instructions, please go to support.cadence.com, where you can access the lab and training course that will guide you through the Security Topology Workbench tool with System SI for parallel bus and serial link analysis. Start by double-clicking the controller block to open the Edit Properties window. Ensure that Ignore VT Curves is not checked, Ideal Power is checked, On-Die Parasitics is not checked, and Package Parasitics is checked. Similarly, double-click the memory block and ensure that Ideal Power is checked, On-Die Parasitics is not checked, and Package Parasitics is checked. Click on the Terminate Unconnected Pins under the Simulation Setup pane. Click on Restore Defaults to set default settings to the unconnected signal and power pins. Click on Tools, and then select Sweep Manager, and click on Run Sweeps. A few pop-ups will occur. Click on Yes to the notice about multiple iterations running. Name the simulation file something that will be easy to interpret, such as DDR4 SBPS Sweep, Sim1. Lastly, click on No for the notice about specifying the minimum transmit setup and hold times. In the Report Generator form, select DDR4 2400 from the drop-down menu for threshold. Enter 100 in the AC threshold field, and 75 in the DC threshold field. Uncheck the box for worst-case summary only. Close this window by clicking on the X. Click on Yes to the prompt about saving changes. Click on each of the results in the Sweep Manager to view the simulated waveforms. To view eye diagrams, click on the eye diagram icon in the ribbon. Select DDR4 2400 from the pull-down menu for the AC-DC threshold. Click on the threshold toggle icon to view the input thresholds on the eye diagram. To read the aperture width of the eye diagram more easily, deselect all the nets in the curves pane except DQ0. To view the jitter density plot, first toggle off the AC-DC thresholds by clicking on its icon, and then click on the edge of the jitter display mode field, and select the density option in the pull-down menu. You will see a density graph overlaid on the eye diagram showing the jitter density between the eyes. Finally, to measure delays between different simulated waveforms, we will need to view the other sweep cases. The case that we are looking at now, data_write_top_top_3, is the 700 picosecond delay case. The folders ending in 1 and 2 are the 300 picosecond and 500 picosecond delay cases respectively. First, turn off the jitter density plot, and then check on all the remaining DQ nets that we had previously turned off. Then expand the data_write_top_top_2 folder, expand the RxMem folder, expand the DiePad folder, expand the data L folder, and then check all the DQ nets to view them simultaneously with our 700 picosecond case. Right-click anywhere on the plot window, and select Measure in the pop-up menu. Click and drag one of the vertical markers to the crossing points of the eye diagram corresponding to the 500 picosecond case, and drag the other vertical marker to the crossing point of the eye diagram for the 700 picosecond case. Note that the delay is approximately 200 picoseconds. To view a tabulated report, go back to the Topology Workbench window, and click on Generate Report. Ensure that the boxes to the left of waveform quality, eye quality, timing, and delay are all checked. Clicking the Generate Report button will create an HTML file that will have all the results of the simulation within. This concludes the simulation and results analysis of our topology. Please refer to the additional training bytes in this channel to continue learning about the Security Topology Workbench tool with System SI.